Section 10.2 part 3 video. And yeah, there is a lot of stuff in section 10.2. Here's where we left off. The beaver logs, get it, beaver, is telling you a whole bunch of information that I'm going to try to condense for you here. Previously, we had stated that the base had to be bigger than 0. The base can't be negative. Well, a little example for you. If the base isn't negative, so here's a base of 2, it's not negative. And if I raise it to an exponent of 1, I get a positive number. Raise it to a bigger exponent, I get a positive number. But what happens if you raise a positive base to a negative? I have no idea why I wrote a half. Let's say that was negative 1. Here's what I was thinking. Negative exponent means move it to the bottom. Move it to the bottom. Do you recall what we do to the exponent when we move it to the bottom? We make it positive. So that answer ends up being 1/2, but that's still positive. That's positive. That's positive. So if the base is always positive, that means the answer that you get is always going to be positive, or the argument. So here's what the beaver is saying. If the base is bigger than 0, then the argument has got to be bigger than 0 too. So you can't get negative answers for these. You can't get 0 for an answer either. So that was something you had to check for the equations. This is something that makes the inequalities a little bit different, a little bit more difficult. So let's check out number 13. So right away, it says log base 5 of x is less than 2, and x is in the argument spot. The argument cannot be negative or 0. So I already know that x has to be bigger than 0. So if it's bigger than 0, where's the cutoff? It's smaller than what? That's where you have to go ahead and change this to exponential and do it like the previous problems. Now, I'm going to change up a little bit here. So I'm still going to say the base is 5. The guy in the end is still the exponent. But if it's an equal problem, it doesn't matter if you write the equal sign on the right of that or on the left of that. Equal is equal. Both sides are equal. But there's a less than sign. So my advice to you is this. You either have to memorize everything that the beaver has to say in that call-out box, or leave the x where it was. So x was on the left side, followed by a less than sign, then the exponential conversion. So solve this guy. It says 5 squared. 5 squared is 25. So I have to put these together. Now I'm going to do this one time and one time only. We've done this earlier this year. You could do the number line thingy. I got 2 answers, 0 and 25. X is greater than 0 would go that way. X is less than 25 would go that way. Where do they intersect? They intersect right there. So from here on out, I'm not going to bother doing that. I'm just going to say, as far as the final answer goes, you already know that the answer cannot be smaller than 0. There you go. The answer is bigger than 0. And we solved it to find out that the answer was less than 25. So the graph, the number line graph that we just did right here, would represent that answer. So I'm going to try to skip the number line graph from here on out. Hope you follow. All right. So we already know x is greater than 0. Has to be. I'm going to do the same thing as before. I got an exponent. I got an argument of base of 4. Get it right, Mr. Paul. Got an exponent of 3. I'm going to leave the x where he was. Greater than. Solve this guy. 4 cubed is 64. Well, here's why I don't need to bother with this. If we're saying over here that the answer is bigger than 64, well, that's already bigger than 0, so I don't have to worry about that guy. So the greater than problems are going to be easier to solve because all you would have to do is solve it kind of normally, get that number 64, done. So the less than problems, and this is what the beaver was saying, the less than problems will appear like this. The greater than problems will appear like this. So memorize it, I guess. That's probably the best way to go. So a little trickier over here, less than problem. I already know my answer has to be bigger than 0. It's impossible to be a negative number. Usual procedure. I got a base of 2. I got an exponent of 4. I'm going to leave the x where it was. Solve it. Now, the solving part's easy because all you have to do is pick up a calculator and figure out the 2 to the 4th power is 16. But the writing it part does concern me. Bigger than 0, smaller than 16. The answer falls between the 0 and the 16. Bigger than 0, smaller than 16. So here's where it gets even a little trickier. It can't equal 0, so I'm not putting an equal sign underneath there. But according to the answer we just came up with, x could be less than or equal to 16. So I do have to put that less than or equal sign in there. So again, less than inequalities always look like that. Greater than inequalities always look like that. All right, I'm going to go ahead and try to squeeze these two in. So property of equality. Finally, we're going to hit something that's extra helpful that you're going to like. Notice log base 7 on this side, log base 7 on that side. They disappear in x equals 3. So property of equality, kind of like saying, all right, if I didn't have those, it'd still be equal. I get to cancel them out. So if you have one log on one side, one log on the other side, same base, you get to cross them off. Good news. Log base 6, log base 6, same, gone. I'm just left with the arguments. And I can solve it like normal. I'm going to move that x over. I'm going to move the 7 by adding it. I'm going to divide by 2, and I get 10. Now, the only problem is you got to check it. The reason you got to check it is we just got done saying the arguments can't be negative. So I'm going to plug the 10 in there, and I'm going to do it in my head here. You could do it on a calculator if you wanted. 3 times 10 is 30. 30 minus 7 is 23. Positive 23. Good to go. Better check the other side. I put a 10 right there. 10 plus 13 is 23. Positive 23. Good to go. I'm allowed to have that. So example 17, log base 5, log base 5. Finally, a property that makes life easy for us. Quadratic equation, people. We've done quadratic equations clear back in chapter 5. Chapter 5 said you could solve it using quadratic formula. If you have a graphing calculator program, congratulations, you can run it. But either way, I have to have 0 on the end for these. So, I'm sorry, that's a 2. I have no idea why I wrote a 1. So the alternative is always, when in doubt, factor it out. P and P, only way to get 2 is 2 times 1. If I'm going to get a negative 2, I need to have opposite signs. And if you were to take the time to check that, you do end up with this negative 1p in the middle, so it must be right. What makes 0? Switch the signs, I get a 2. What makes this guy 0? Switch the sign, I get a negative 1. Not too bad, assuming you remember how to do quadratic equations. And if you ran your calculator program, assuming you had one, it would have told you to a negative 1. Life's easy. Here's why life's not easy for this. They are arguments. We were looking for an answer for p that's in the position in the log problem of argument. The argument cannot be negative. It cannot be 0. So I need to check these guys, thus the check symbol. So right here, if I were to plug a 2 in, 2 squared is 4. 4 minus 2 is 2, positive 2, that checks. If I were just to put the 2 right there, it would say log base 5 of positive 2. That one's okay. P equals negative 1. Put a negative 1 right there. Negative 1 squared is 1. 1 minus 2 is negative 1. I would get an argument that's negative. So this guy does not check out. I can't have him. So I will give you a heads up in the notes, the written notes that are online. For some weird reason, I wrote the check symbol out here, but then I never actually did the checking process. So on that particular set of notes, the written copy online, it doesn't have this guy crossed off, but it should be. So shame on me for that. But again, got to check, guys, and we know for equation solving, checking is always a good idea anyway. That's part 3. Thanks for watching. Stay tuned for part 4.